Hi everyone, it's Mr. Barden here. On the day that I'm recording this, it's a little bit chilly, so I got a sweater on to get through everything. What we're going to be talking about today are virtual synthesizers. I've got a whole bunch of stuff on the monitor here to talk about, and then we're going to end it off by coding and creating one. I say end it off, that's going to be the bulk of the video, but we'll be doing this in P5.js and using the Tone.js library to do so. Before we hop into the code, however, I want to talk just a little bit about what it is we're doing and the main parts involved there. So I've got on my screen an interface for some virtual sample synthesizers that I have. I'm not here to break down every single thing, but generally the way a synthesizer works is that it, well, synthesizes sound electronically. So I've got this one hooked up. Just played a few notes there. And the way this one is working is that it's just a software program on the computer. The computer has all of the stuff in order to make the sounds, and we're just controlling it with an external device, in my case, this keyboard. If you knew what pitches those were, go ahead and type that in the comments. That'll be fun to see who has perfect pitch in the viewing community. But there's a bunch of different ways that we can make this. This is more sample based and modeling, so it's made to sound like a real live instrument. In this particular collection, this isn't sponsored, by the way. It's just one I use for a lot of stuff, but it comes with a ton of different piano sounds. You can find all kinds of different stuff depending on what you need for different synthesizers. Maybe we wanted this one. I think I had one of those growing up. Anyways, again, you can change it all up and it does different things. It's still the same synthesizer, though. It's just utilizing different parameters. I said the phrase sample-based in modeling a little bit earlier, and basically there's kind of two main ways, speaking broadly, that the synthesizers will work. One is that it's, again, generating the tone from scratch and doing a ton of math involved to make it sound like something, and the other is that it takes, recorded samples from live instruments and plays or otherwise edits and models those recordings, again, in order to sound like a real thing. The way we're going to go about it doesn't quite do that, although you could, with some of the math in Tone and the more complex synthesizers, do something a bit more realistic. So we're going to close that. What I've got on the screen right here is just a quick Google search for synth waveform diagrams. So here's the way that this works. In a hardware, physical synthesizer, not a program on a computer, they have an electric circuit. And this circuit, when it's powered and turned on, will output electrical voltage in a variety of patterns. I've got kind of the four, what we call the simple, the base oscillator waveforms right here. We have sine, square, triangle, and sawtooth, and we'll hear all of them by the end of this video. Again, there's more, but they're pretty much all derivative of these four different combinations or transformations of them. Just to briefly talk about it, the electrical voltages coming out of that circuit, we have the sine where it's kind of a smooth gradient between high and low voltages, square where it just jumps back and forth, triangle where we move linear, and I like to think of sawtooth as a combination of square and triangle where it moves linearly and then jumps back to a different state. These all have unique sounds, and again, we'll hear all of them, but the idea is that you output this voltage, and then through a variety of other things, we change how the sound sounds. And that's what gives synthesizers such a wide variety of potential timbres with very minimal controls. So that's the main part right there, is that we are going to be telling the computer which waveform to output and how fast to output it. And what that will do is change the pitch or the frequency of the sound. If we're outputting this pattern at, 20 cycles a second, we're going to hear a frequency of 20 hertz. If we're outputting it at 440, we're going to hear it at 440 hertz, and so on and so forth through the whole range of everything that we can hear. So that's the first part. We're going to start with that. But before I hop into the code or anything, I'm just going to mention I've got the tone reference right here. And this is going to be very helpful. I specifically have the synth page pulled up. Now, there are additional synths under the instrument category over here on the left side of the screen. We have an amplitude modulation synth, which does, well, amplitude modulation. A duo synth has 2 voices. FM synth does frequency modulation. I'm not going to break all those down. Membranes sound like you're hitting a drum. Metal sounds like it's a metal thing. Noise, I mean, that's pretty self-explanatory. Pluck is like you're plucking a string. Poly does a bunch of stuff, a bunch of different voices, and sampler takes in audio samples and pitches them up and down. That's, again, a real brief overview. We're not going to talk about these today outside of that little paragraph. We're going to focus just on the main synth. And there's actually a diagram on this page, which is very helpful. So I've already talked about the oscillator, and again, it's not going to be a physical circuit coming from the computer. It's going to be a set of code and instructions. So we're going to basically be generating numbers that follow this pattern between -1 and 1 in the computer's memory. Just, ooh, there we go. There's all the numbers. And then when it gets sent to the digital to analog converter in your system, then that will change it to outputting the electricity that drives your speakers or your headphones or whatever. So those are the 2 parts of it. We have to generate the sound right here. That's all that's going on, and I realize that's not the second part. We send it through a thing until we get to the output. This thing, the amplitude envelope, well, the amplitude is, for lack of a more specific definition, the volume of your sound. And now the envelope is essentially how that volume is going to change over time. I like to think of it as if you're taking a physical envelope or some other container. I just happen to have a box on my desk here full of resistors and circuit boards. But, if this was the envelope, we're shoving that sound from the oscillator into it, and it will now fit the constraints of this envelope. In practice, these have 4 parts, and we'll see it later. We can actually open up the reference page for the amplitude envelope, but this is also called an ADSR, or an envelope, and that's because every envelope has 4 main parts: the attack, decay, sustain, and release. The attack is when the note, there's no note and then it starts. And that's just how long it takes the note to get to its maximum volume. There's usually a little bit of a decay after that in terms of volume of the sound. Doesn't have to be a lot. It's usually not. Then there's the sustain amount of the note. Just how long is the note holding for, and then the release as we fade off. There's actually a link to a very helpful Wikipedia page about this, and it talks about envelopes, but right here, if we pull this up, is a diagram illustrating that. So again, if here's when you press the button, you want to make the sound happen, and as we're moving along time here, the volume will increase for however long the attack portion is. There's, again, usually a decrease. I like to think of it as kind of like the initial extra energy you need to start playing the note is kind of that little hump right here in terms of volume. The sustain, again, that goes for as long as you're holding the note. Sometimes it's really long, sometimes it's really short. That's how you get the difference between, going boop, 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 boop on a keyboard versus doop, 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 doop. Again, it's a much longer sound. And then the release is just the fade. We'll play around with these and hear all of that. But that's, like I said, the main 2 parts. The oscillator, the part that makes the sound, and the envelope, the part that shapes how the sound is played whenever you trigger it. These 2 things are needed, and luckily the synth object in Tone combines all of that into one thing. So now we're going to hop over into the sketch. And this sketch will again be in the description like just about all of my other ones. I've done a little bit of prep work, but not a ton, and I'm just going to break that down. I've gone ahead and loaded in Tone, so that's already there. If you don't have Tone, you're going to need it, otherwise none of this will work. I've called up function preload, but haven't put anything in there. My Google Translate things are popping up as I look at the screen. And then I've made a set of callback functions here. We're essentially going to make a musical scale. We're going to play through a C major scale, and I've made a callback function for every note in that scale. We'll talk about how this will work when we start actually triggering the notes. But let's just make a synthesizer right here. So we're going to say let my synth right there. And I'm doing this in preload. You don't technically have to, because we are not loading any audio content with a synthesizer, nothing external from this program. We are just telling the computer how to generate it itself in real time. So because of that, we don't need to load all of this up beforehand. However, I like to try to keep all of my stuff, together in appropriate little bundles and areas in my code. So I'm already using function preload to load up any sound files. Well, in my mind, those are sound sources, so I'm also going to be making my synthesizer and putting it here, so just all of my sound sources are in the same place. I'm making all of them in the same spot. Again, you don't have to do it in preload. I just do it because, that for me in my brain, that makes sense. So my synth equals a new tone.synth. Just like that. And there's an example right here. We've got all of that. And that's pretty much the 2 lines you need in order for it to run, is make the synth and send it to the destination. So .to destination. You can send it other places and use all the audio effects that I've talked about in previous videos with a synthesizer. But for the course of this video, we're just going to send it to the destination and hear it. The next thing we need to do is trigger the synth and tell it what to play. I'm just going to real simply say function mouse pressed, just to introduce this idea. And we'll say my synth dot trigger attack release. Just like that. So if you were to look back at the reference material, you see we've got trigger attack release, and it's got some info right there. We can scroll down to our methods, find trigger attack release, and it will tell you a few things. The first is you tell it what note to trigger. So I'm just gonna say, I'll use the example from before, C octave 4, and then we have to tell it what duration to hold the note for. Now there's a bunch of different ways that we can set all of this up. You can also add additional stuff like optionally, what is the, when will you trigger the note in the future, what volume will it be at, all of that. But you can essentially tell it how long to hold out the note. And there's different ways that we can do it. We haven't talked about scheduling events yet, so I'm not going to focus on, putting things in beats and bars and relative stuff like that, but we can just do it in time. And this is in seconds, according to that reference, so we should say, comma, 0.5. And now, if I run this, if I click the mouse, we should hear the note C4 play for half a second. We've played that. If I change this to 1, we should hear it now for 1 second. I don't know if you can hear the little discrete parts of that attack envelope, but there's definitely a fade in and fade out with the notes. If we did not have the envelope, then the synth would just output output the sound forever at a constant, rate. It would just forever go. Sometimes you may want that, but in most musical contexts, you won't, because you want to be able to control when you press the note and, play, stop, that kind of thing. It's like a keyboard. But again, without an envelope, it's just outputting the electricity, or in this case, the numbers, constantly. There's a few other of the methods here, the trigger attack and trigger release, which just tells it to start or stop a note. The trigger attack release combines them into both. So again, it's very, very handy. Okay, I want to look at envelope. There we are. So again, we can set up an Amplitude envelope and actually control this utilizing JSON formatting. So if you go into where you make the tone.synth, open it up with some curly braces, we can then use JSON formatting in order to tell it what to do. So in order to do that, I didn't pull it up, going to pull up some textbook pages just to show some of that, and then we'll type it out ourselves. So looking at synthesizers, again, a lot of this is all right here. I'll put a link to this, as always, into the description of this video, but I just wanted to pull off a few things, and there's just a lot of helpful diagrams here. So this is what we're doing right now, but with the envelope, not the oscillator. So we'll come back to that in just a moment for the oscillator, so we can hear all of them. But I've attached here an image of a full 88 keyboard, just like this one, and each key is labeled. So if you know what pitch you want to play it, you can just say, hey, play, in our case, C4, like we did. You can also just say, play a number, play exactly 521 hertz, and we should hear, there it is, if you wanted to play 520 hertz. I don't know if you could notice a difference. Those are very close, but we'll just put it at 500, and now it's a little bit lower. So again, you could do this numerically or pitch based and musically based with a keyboard. It depends on kind of what you're doing and what you want to do, and kind of your aesthetic. Again, if you're wanting to make more of a tool for musical content and composition, you may want to go more with the pitches. If you want to do something a little bit more mathematically based, you may want to go with the numbers. Again, we'll talk about that oscillator stuff, but we can actually change up the envelope. So if we head into here, we can actually say envelope, and then looking at the bits, we can just specify attack, decay, sustain, and release. So open it up with another set of curly braces, and attack, decay, sustain, release, just like that. And by default, you can see what they are right here. Sustain, I usually keep at 1. You can change that up, but let's just do 0.6 for now. I don't know. Attack, we'll keep, we'll make it a little bit longer, 0.3. Decay, we'll keep short, 0.1. And release, we will say 0.3. I'm just picking some random numbers. These all need to be separated by a comma. That's why it's angry at me. There we are. And now if I run this, we should hear a different shape to the sound. That's a little bit different. Let's make this 1. A much longer decay. If we made this 0.8 instead, you can hear how it had a much longer fade in, 0.5 here. And so on. Again, if we made this 0.2 instead, it would be a much shorter note, or much shorter sustained portion. And again, 1 And we'll put this at 0.5. And again, so you can really change up exactly how you want to shape the note. Again, you could have it kind of grow. You could have it be a real slow fade in and quick cut off, a real fast fade in with a real long fade out. It could just be a quick hit. There's a lot of variety right here. So that's how we can change the envelope of the sound. The next portion is what I hinted at a while at the beginning, and that is adjusting the waveform, the oscillator type. This will be a much more noticeable change in sound. So what I'm going to do for this is go, we've got this little portion right here for the envelope. I'm going to go to right before it, and we will say OSCILLA, oscillator, colon, braces, and then after the braces, it needs a comma to separate the oscillator from the envelope, but we will enter in to that and give it the information. And we can just say type and give it a type. The types are, if we look under property to oscillator, boom, it's for the omni oscillator. We can head over to that and look at that type. Type, and it basically in the oscillator object right here, we can look at the oscillator types, and all of these four that I've mentioned initially, I closed out that tab, but the sine, square, triangle, and sawtooth are there. You can also add prefixes for frequency modulation, amplitude modulation, or fat to swap over to these other oscillators if you want. You could also set it to pulse width modulation or pulse. In order, again, this all changes the sound and exactly what the pattern of numbers coming out of the synth object is that gets sent to go change the sound. I'm just going to focus on the basic ones. So as a string, sine. And if I run this and click, we should hear basically the same thing. Here is a little bit different. Again, there's some default settings versus this one. And a sine is a very pure tone, no overtones to it. It's just the note. I always forget the quotations. Square, right there, has a different kind of collection of overtones. A lot of times you'll hear a lot of like clarinet type instruments modeled using variations on a square wave. That's not a great, everything else to sound like a clarinet, but because of the combination of stuff, I realized I forgot about that. Hopefully I haven't been erasing things as I've been typing. We're just gonna do this. No, we're not. We're gonna do this and remove this, and I'm not gonna bother editing this out because I'm busy. There it is. All right. OBS and presets and saved key commands. Anyways, where was I? Oh, yeah, so you can change up stuff. So I've changed the pitch to lower it. Again, just to hear some more low pitches with that sound. A triangle wave sounds like this. It's kind of like a combination of the square wave and the sine wave. It's still got some of those kind of overtones. It's not just a pure sound, but it's not nearly as piercing as a square wave can be. And the last one, a sawtooth, sounds like this. That one's, again, incredibly buzzy and noisy compared to the others. So they all have different combinations of sounds. You can find what you like. You can swap it up. You just have to change the thing. So maybe instead of having my mouse here trigger this pitch every time I click it, let's do something else. Let's say let synth types equal an array, and that array will contain sine. I'll do them in the same order I typed them in before. Square, triangle, and sawtooth. I should have done it like this. It's important that you notice that things like triangle and square, those are all functions in P5. So just make sure that a lot of this is done as a string. So I have that right there, and we're just going to change that in real time. So instead of doing that, I'm going to say instead my synth dot oscillator, Lator, dot oscillator. So again, your synth, the oscillator, and then we have to do the sub property of type. So my synth dot oscillator dot type will get assigned to be a random value from the, what I call it, synth types array. So now we'll pick a different one. We won't actually hear it because now I've changed that. So let's just put this back for a second, and now we'll hear every time I click a different type. You get the idea. What I'm going to do now is actually set up the last portion I've mentioned right here in these comments, and that is being able to control this with a variety of methods. One will be some on-screen buttons, the other will be the number row of keys. So let's start with the number row, because that'll be just a little bit easier. So what I'm going to do is hop down. We'll go to right before all of these callback functions I've made, and we'll say function key pressed, just like so. And I'm actually going to do it like this: console.log key code, so we can remember, because I don't have those memorized. And we're going to do it with a switch. Just like so. And then we'll say key code. And then, is it the braces? Yeah. Open that up. And then case. It's not going to be happy with me until. Look at that. So let's just refresh this. One is, I'll type these in order. 49, 49, 50, 1, 2. We ended at 57. 49 to 57. Just like so. Okay. Case. Is it a colon? I just want to double check. Here. Actually, I got this pulled. No, wait, it's not there. We're just going to Google this because that's not actually up there. Switch. JavaScript. Just to make sure I've got the formatting right. Okay, yeah, it is colons in there. All right. So let's just uncomment this. There we are. Boom. You can tell I don't use switches a ton. But case, colon, 49. And then we're just going to say, oh, it's case 49, colon, my bad. And what we're going to type in there is what we want to play, which will be the trigger.attack release. And we'll tell it to play specifically musical note C4. Just like that. And we're going to just go on. Then we'll say break. Next one. Case 50. Paste. And now we'll change it to D4. You can kind of see where we're going with this. Each note, each number key on the keyboard, which is 1, 2, 3, 4, 5, 6, 7, 8. Those are the key codes for it. So whenever we play, we press one of those buttons, we are going to then say, hey, what was the key code? If it was 49, we're going to do this. If it was 50, we're going to do this, and so on and so forth. So break. Case 51. And we'll change it from D4 to E4. The capital letter doesn't really matter there, but I like to have them all look the same. Break. Case 52. Paste. F. I'm doing all the notes in just a basic C major scale. If you want to do other scales, you definitely can. I'm not going to break all the scales down in the music theory for that right now. Case 53. G. Break. Case 54. This is a little repetitive, I'm not going to lie. But we're almost there. B4. Break. As I'm typing this, I'll just mention the letter in a note name, if you're unaware, is again the pitch within the octave, essentially. So, you know, B flat, G, C sharp, all that kind of stuff. It's there. And then the number is the octave. So if you had, in this case, I'm just talking about 57. Oh, it's because I forgot A. There we are. So if in this case you typed in B, if you had a B3 versus a B4, the B4 would be one octave higher than the B3. Again, so why'd I go to 57? Anyways, 49, 50, 51, 52, 53, 4, 5, 6. Yeah. And then lastly, they all reset at C, so the last note will be C5 to play the high note. Break. We could give it a default if we play anything else. And why not? Let's have, if we play anything else, we'll have it play a super low note. The lowest note on the keyboard normally will say A0. I don't know what just happened. That did some weird stuff, but A0. There we are. So, and then, does that one need a break? Doesn't appear, so I'm just double checking. Doesn't look like it. All right. Again, you can tell I don't use switches that much, but if I refresh this, hop over here, that's again from that mouse pressed function. But now, if we kind of do all of that, let's click back over here. And then if I press anything else, there's that really low note. So again, let me just break down what I was doing on my normal keyboard here. We have again mapped using just the normal key codes that happen every time you press a key. We say, hey, we're going to do a different thing based off of the key code. If it's this particular number, which happens to be number 1 on the keyboard, the number row, we're going to play the pitch C4. So let's go. There it is. That 200 hertz from up here is bothering me. So we're going to get rid of that and refresh this. We'll randomize that type a bit, and I'll press 1, 2, 3, 4, 5, 6, 7, 6, and 8. So we can play those notes, and you can play them again in any order. Messing around a little bit. And we've essentially just made a synthesizer with a not that great keyboard interface, but it would work. So again, if you wanted to make an instrument, that's how you do it. You just have to make a synthesizer and in some way trigger the trigger attack release method and tell it what note to play, and there you go. That's pretty much it. because of that, I'm actually going to swap up how I've got this formatted. So this is where all of these functions come into play. So if I copy this and paste these lines down here, copy, paste, copy, paste, and so on and so forth. And again, this part of the video is a little bit repetitive. So I'll use this to say, if you've got any musical questions or like just general questions about anything I'm doing, definitely put those down in the comments. Take a second just to do that right now while I'm just literally copying and pasting a bunch of stuff in mine. Copy, paste, and the last one. So again, I love to answer questions people might have, and let's make that look a little prettier, tidy that up. All right, so now instead of saying trigger, attack, release in all of these, I'm just gonna say play that note. So let's do that. So instead of that, we have play low C. And then I have play D. This is just gonna, again, copy, paste, 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 and paste to make my life a little bit easier. E, F, G, A, B, and I, C. Tidy all that up, refresh it, and again, we should have the same thing. There's some stuff happening there. But again, same thing. I've just tweaked up how it's getting called. I've moved it, so instead of calling it right in the switch, we're calling it with these functions down here, because I would like to make some buttons that also go on the screen in order to set all of this up. This isn't anything new if you've been following my videos, but we're just going to hop that up right now and make some buttons. Let, caps lock off, let, we'll say low C, D, E, F, G, A, B, I, C. These are horrible names in most contexts, but since we're literally doing nothing else in the code after this, and this is all the code is going to do, it can work for now. But we're going to make each of these into a button. So I want to move mouse pressed down to by key pressed. Put it down there. So I'm just going to go into setup. Low C equals create button. I'll say, well, I'll just give them the name. Low C. Actually, we'll use solfege names. Do D equals create button, and that one will be Ray. The reason I picked the C major scale is because whether or not you use a fixed or movable do, this will still work. So D is there, E, F, G, A, B, C, B, and I, C. This one will be do, re, mi, fa, sol, la, ti, and do. So now we've made the buttons. You can see them all right there on the bottom of the screen. I'm going to make my screen, I don't know, a fun color while we're at it. But we've got all that right there. Now we're just going to hook all these buttons up to these functions down below. Because again, all we need to play the note is the trigger, attack, release. So by storing it in a function, we can just refer to that function wherever we want. So we can have multiple ways to play the same pitches. So let's do it like this. Again, I'm copying and pasting to make my life a little bit easier. We're just gonna delete this extra stuff, so it's just the names for now. And I'm just gonna keep the buttons at the bottom of the screen, because that'll work. And we'll just say the button dot mouse pressed, and we just tell it what function to play. So we're gonna start with play low C and just go down the line. Play low C, low C, and again copy and paste. And we'll just update all this to play D, play E, play F, G, A, B, and play high C. Some lovely little callback function. Tidy that up real quick. And we've essentially done all the stuff I said I would do in this sketch. I've refreshed it. You can see the color change now. So now we've got all this stuff. So let's just break it all down and then we'll play around. Let me make sure it's working. Cool. All right. So will this play a different pitch now? Or different? Will. Okay. Different oscillator type. So we have made a synthesizer. It's just being hooked up to the destination speaker. No effects and anything. That'll be, again, a separate little video. You can just make the default synthesizer if that's what you want, but you can change the oscillator type as well as the parameters of the envelope if you want to. So if you know you really want something to fade in and cut off pretty quickly, you can set that up yourself and really fine tune all of that. You can find the exact settings here under the properties of the Amplitude envelope. So if you know you wanted to go to attack, you can see, they got some helpful diagrams, what the ranges are, all that stuff there. So you can find out all that stuff. You can also change how it gets there. So it could be, curves instead of straight lines. I'm not going to break that down right now, but you could, control that if you really wanted to and really, really fine tune all of your sounds. Like here's the decay portion and all of that. There's a lot of stuff you can play around with. And again, all that this is doing is just generating a bunch of numbers, and those numbers then get sent out to the speakers to be converted into electricity. Then it plays a sound. That's literally all that's happening. I have it set up so that way we can control and play this synthesizer using the number keys. Or we can use these on-screen buttons. All right. I'll quit messing around with that. The reason that this was changing when I was clicking the mouse is because I still have this function mouse pressed. That's just every time I click the mouse, it will randomly select an oscillator type from this array that we made up at the beginning. So that's why that's happening. I then have, again, all of these callback functions, and they all have a variation on the trigger, attack, release. And actually there are even better ways that you could go about this. Really, you could get away with just having one function with an argument that tells you what pitch to play, but we're not doing that for today. I purposely wanted to make this a little on the repetitive side so you can just see it done a whole bunch. But by putting the command to play a note inside of a separate callback function, you can then just refer to that function anytime you want to play that note. So I have here in key pressed, again, all the stuff for controlling it with the key. We just look at a key, tell it, hey, play that note, and it does. Actually, we don't even need the console log anymore. Or in here, we can just hook it up to the button and say, when this button's pressed, play that function. That's pretty straightforward. And that's pretty much the core of it. Again, you can kind of hear some of that changing as the oscillator changes while the note's still going on. It's kind of fun. But that's the basics of just making and hearing a synthesizer. We'll be spending a little bit more time on this, building different ones and exploring some of the different kinds. And then ultimately, we will be talking about how you can have your synthesizers automatically play stuff. So that'll involve the sequencing that I briefly mentioned when I was looking at the time durations for the Amplitude envelope. So again, once we can have it automatically play stuff, we'll then start implementing them into some basic games. And that'll be the kind of the next big game that I make on the channel, will be one that takes all the stuff from P5 Play and adds this into it. And we'll kind of build that up from scratch and implement a soundtrack to it. So that's the goal there. I'm just trying to figure out what kind of game I want to do. So if there's a particular kind of 2D game that you want to see, let me know. I'm wanting to steer away from platformers and things involving gravity, because that's just extra steps that's not super related to what we're wanting to do, and they can be their own kind of thing. So anyways, I hope you found this helpful. If you enjoyed the video, if you learned something, definitely like, comment, subscribe, all the YouTube stuff. It is very helpful for the channel and everything that we do here. So I say we like it's more than me and my cat, but that's going to be it from me today. So, YouTube stuff, rambly outro, you know the deal if you've seen a bunch of these videos before. This is where I'm going to end it, and I will see you the next time that I see you. Bye.